Hi everyone. So welcome to the next chapter. Chapter resistive circuits. In the resistive circuit, the first topic is the series circuits. So in this particular topic, I am going to explain what is series circuit, what is the formulas related to the series circuit. So by look at the circuit, three resistors, right? Three resistors are connected. So these are connected. One end of the terminal is connected to the first end of the terminal, and then here the second end of the terminal is connected to the first end of the terminal, and then it is connected to the some battery. So this type of connection we are known as a series connection. In this case, the current will be flowing, the same current will be flowing through the all the resistors. So see here, when a components of circuit connected end to end, so that circuit current passes through each component, they form a series circuit. So whenever you are connected like that, the current will be flowing through the all the resistors are same, then it is called as a series circuit. So the first condition, in case of series circuit, current is the same for all the component, then only it is called as a series circuit. Okay, so the same circuit here connected, one end it is connected to the supply, other end is connected to the ground. In this case also, the current will be flowing through the all the resistors are same as well. The one end of the wire is connected to the second end of the first terminal. Here also second end of the second resistor is connected to the first end of the R3. So this is also called it as a series connection. In case of series connection, what will happen here? The current, if there is a resistor R1, R2 and R3 are series each other, the battery and also battery, the result is only one path of flow of current. Very important, only one path of flow of current, hence the current I is same for all three resistors. So every student have to remember in the examination point of view, in case of series circuit, current is same. In case of series circuit, current is same, right? What about the voltages? See here, the voltages, whenever current is same, the current will be passes through resistance R1. For example, here, if current is passes through resistance R1, according to Ohm's law, V1 is equal to I into R1. That means some current will be dropped, some voltage will be dropped across resistance R1, right? So in case of series circuit, the voltage will be dropped across each and every resistor. The drop will be different. Here V1, V2 and V3. So these drops, that means the second point you need to remember, voltage drop across each component whenever connected to each component. Okay, clear? So here current is same, voltage is divided. So voltage drop across each component is different. That means voltage is divided. So finally, conclusion, voltage is divided. Voltage is divided. Right? Everyone note down these points, very important in the examination point of view. Clear? Now, I will do the derivation. What equivalent resistance, how to find out. So, total voltage V is equal to V1 plus V2 plus V3. Okay, according to KCL, supply voltage is equal to voltage drop across each resistor. Already I mentioned voltage drop across the V1 is resistance R1, voltage drop across the V2 is resistance R2, voltage drop across the V3 is resistance R3. So whenever V, according to Ohm's law, V is equal to IR, where R is a total resistance. Next, I is a total current. So look at here, V is equal to IR, right? I into total resistance is equal to V1. The current is same, so I into, because this is a series circuit, I is equal to, for example, I1 is equal to I2 is equal to I3. If your case the current flowing through the R1 is I1, all the currents are I only. So that's why I into, what is a voltage drop across resistance R1 only. So R1 plus I into R2 plus I into R3. If you got my point. Now this particular I get cancelled in the left and right hand side. Finally what you got, R equivalent and total resistance is equal to R1 plus R2 plus R3. This is the formula to find out the equivalent resistance. Maybe in the examination they will ask you this formula, otherwise they will give the some small circuit and find out the total resistance. In the next examples we'll look at those problems. So it is clear up to series circuit. We need to remember these points. Current is same, voltage is divided, the equivalent resistance is equal to R1 plus R2 plus R3 and so on, based on the number of resistors you are connected. Okay. Next one, characteristics of series circuit. Look at here. So what are the characteristics we have? So just now we discussed the previous topic is a series circuit concept of total equivalent resistance that will use here. The first characteristics here, total resistance equal to sum of all resistors. Just now we proved that total resistance is equal to sum of all the resistors. So according to the particular characteristics, just tell me what about the equivalent resistance, all three cases. For example, the first case in the first figure, so two resistors are connected in series or parallel. Look at here, the current is same. So current is same throughout the circuit. It is a series. You know what is the formula? Summation of all the resistors, R1 plus R2. In the second circuit you need to go through that. In this case also maybe it is connected zigzag manner, but see the current path. Everyone listen. The current will be flowing like that, and then the current will be flowing to the resistance and then ended here. Current path is single path only, na? So definitely those resistors are series only. R is equal to again R1 plus R2 for your understanding purpose. So it is not directly connected, it is a zigzag manner also connected. Look at into the path of the current. No doubt about the way to connect the circuit, maybe zigzag manner or Z manner, what it may be. It is a equivalent resistance is equal to summation of all the resistors. In the case of single path, current is a single path only, it is a series circuit. Coming to the third, C. In the case of third circuit, current will be passes here, and the same current will be flowing through this. Same current will be flowing R3 and then ended here. That means single path only. So that is R is equal to R1 plus R2 plus R3. And then last one. In this case also, see, current will be started from here. Okay, current will be flowing. This is the way the same current will be flowing. There is no division of current here. So current will be the same all the cases. So R is equal to R1 plus R2 plus R3. All of you got first characteristics. What is the first characteristics? Total resistance is equal to sum of all the resistances. So this is a proven. Okay. Next, coming to the second one, current through all resistors is same. Already mentioned, in case of series circuit, the current is same for all the elements. Current is same for all elements. Okay, then only it is called it as a series circuit. If current is different, it is not obey the property characteristics of series circuit, it is not called it as a series circuit. You should obey the series circuit, current is same. So that is one of the important characteristics. So next one, sum of the individual IR drops equal to the applied voltage. Already mentioned in the just now 5 minutes back in the starting itself. So supply in the derivation, supply voltage is equal to sum of all the voltages V1 plus V2 plus V3. We need to obey this particular characteristics also. Then it is called it as a series circuit. Look at here, in this particular circuit, we are applying a 12 volt. What is the voltage drop? V1 3 volt, V2 4 volt, V5 5 volt. What about total summation? 12 volt is equivalent to 12 volt. So here proven, right? Supply voltage to the battery is equal to voltage drop across each resistor. Its summation is equivalent to the supply voltage. So these three characteristics you need to remember. What are the first characteristics? Sum of all the resistors is equal to the equivalent resistance, total resistance. Second characteristics is a current through all the resistors is same. and then third one is a volt summation of individual voltage drops is equal to the applied voltage. So these three characteristics, one of the question you may expect in the theory, they mention these characteristics, the below mention these characteristics related to the series circuit. They mention all total resistance is equal to sum of the all the resistances, current through all resistance is same, the sum of the individual IR drops is equivalent to the applied voltage. D, all of the above. You need to choose option D is the all of the above. Bro, so based on that, if you clear about the all these what we call concepts, theoretical concepts, definitely can answer any objective question. So still we are interested towards all 39 chapters, that means all 5 units from KVS TGT. So you can go to our particular mobile app and then download our app and then subscribe our course. Okay, next we are moving to the case of zero IR drop. So I'm explaining to you each and every topic. What about your syllabus? Just everyone, while you are watching this video, just take your syllabus copy, one of the printout, with you can paste it in your notebook or with you always, and then see what are the topics are explained to you. Each and every topic I explained total 5 units from the syllabus only. I won't deviate the syllabus. I won't explain too much to you. What is required for your examination purpose, what is the syllabus mentioned, that thing only I explain to you. So here the case of zero IR drop. So the case of zero IR drop, just look at the point wise. What is mean by IR drop? First of all, for example, this is a voltage you are applying, this is a R1, this is a R2. Okay, the voltage drop means in case of series circuits, the current will be flowing, the current I, the same current will be flowing R1, that means R1 appears some voltage drop, that is IR drop. R2 some voltage drop. Here IR drop is nothing but a V is equal to Ohm's law according to I into R. Voltage drop across the particular resistance is nothing but a IR drop or voltage drop, you call it as a. So look at the first point. It is obvious that IR drop will be 0 when either I is 0 or R is 0. When IR drop is 0, just look at this particular equation, V is equal to IR. In case if I make I is equal to 0, what about the voltage drop? 0. In case if R may be equivalent to 0, 0 into any current is 0 only, so 0. So that means, so if you want to drop IR drop, make it to 0, either current is 0 or resistance is 0. Now for copper connecting wires, for example, this is a very very important. Here these two resistors are joined some wire, yes or no? I will make some other current. These two wires are joined some connecting wire. That connecting wire, for example, it is a copper, that is mentioned here. For copper connecting wire, R is practically 0. There is no drop because resistance in this connecting wire we are neglected, that is 0. Whenever resistance 0, what about IR drop? It is 0, that is neglected. Hence there is no voltage drop across such interconnecting wires, even though they may carry their normal current. Okay, so practically you need to remember that while your calculation of any voltage drops or any calculations, you don't want to consider the interconnecting wires between the resistors or any other components. If you are using the copper, practically the voltage drop is 0, even though it is carrying the normal current. That is the first point. All of you following? Right. We are moving to the second. There is no IR drop. There is no IR drop. I is 0 when applied voltage has been disconnected. There is open circuited. I will explain now. In case this is a particular circuit, I may disconnect this particular wire. If I disconnect this particular wire, there is any possibility of this current will be flowing from battery or this 12 volt to circuit? No. In the open circuit, current is 0. In the open circuit, current is 0. Whenever this battery is not connected to the particular this component directly, that means what is a voltage drop now? Here current is 0 na? Current is 0. What about voltage drop? It is 0. That is the second point. Even though the battery, the supplied battery is not connected to the circuit, supplied voltage is not connected to the circuit, that case also IR drop is equal to 0. So these conditions IR drop is 0. In the examination point of view, they may give the question like that: zero IR drop is possible. Which of the following cases? The first case, the current make is 0 or R is 0. Otherwise, applied voltage disconnected to the supply, disconnected to the circuit. Last one, all of the above. For example, that type of questions. The option is all of the above. Clear cut idea about this particular topic, then only can answer those questions. This particular topic is not only useful for your theoretical objective question, it is also useful for your further discussion of transistors, diodes, as well as instrumentation concepts, these like bridges. This is a very important concept, so everyone understand clearly this basic idea about all these concepts. Next one, polarity of IR drops. Okay, till now IR drop means voltage into resistance, some voltage drop. How to mention the polarities? Polarity means that whether the positive or negative signs of the particular resistor, how to notate that. I will explain in this case. So see here, look at this diagram. While you look at this diagram, this is the battery, right? 20 volt plus and minus. So this is a series circuit or not? Yes, this is a series circuit. Current will be flowing like that. So in this current flowing, the same current will be flowing to all the resistors, but the current entering into the first terminal, right, this A terminal is considered as a positive. The current leaving terminal, this B terminal, considered as a negative. Coming to here, the current entering this terminal is nothing but a positive. Okay, the current leaving this terminal is nothing but a negative. So all of you got my point. So likewise the polarities. Okay, likewise the polarities again, here current entering the first terminal positive, negative terminal is next terminal, leaving terminal is negative. Likewise the polarities are mentioned in the resistors. Everyone remember just I will explain these points. You got the idea how to mention the polarities? Now look at here. To study of voltage polarities, whether positive or negative, extreme important in the transistor and semiconductor circuits. In the second chapter, third topic, semiconductors, diodes, and then next one is the transistors. Those topics already mentioned in your syllabus. In that particular case, polarities are very extremely important, right? So when voltage drop exists across a resistor, yes, voltage drop exists across a resistor, its one end must be more positive. Yes, A is more positive than other end, that B. That means it is a plus, it is a minus. That means A is more positive with respect to B. Otherwise, without potential difference, for example, here more positive, here more negative. That means here potential is higher potential, here potential is lower potential. Then only current will be passes. For example, there is no potential difference. Without potential difference, no current will be flow through the resistance to produce the IR drop. That means everyone remember, the current will be flowing whenever the potential from highest potential to lower potential. This polarities makes that whenever the potential differences occur, then only current will be passes through this circuit properly. Okay, are we clear about these 2 points? Next we are moving to the next one. The polarity of the drop can be associated with the direction of current flow. Yes, just now explain. This polarity associated with the current flowing. For example, I will explain. For example, this polarity I may reverse, negative and positive. Okay, everyone listen carefully. Now current flowing direction, this is the current flowing direction. Whenever this is the current flowing direction, entering terminal is positive, leaving terminal is negative. Again the current flowing, this is the direction, this is a positive, this is a negative. Again this is the current flowing direction, this is a positive, this is a negative. That means you remember, the direction of current is decided the polarity of the resistance. That is a point here. So the polarity can be associated with the direction of current flow. If the current enters resistor point A, if current enters resistance point A goes out from the B, when A must be higher potential, A must be higher potential than B. right? Just now explain. A must be positive with respect to B. A is positive with respect to B. If you got my point, okay, right. Now you should be clear understood that plus and minus polarity marked in the figure related to the voltage drops across the resistor only. Okay, voltage drop across the resistor only. This polarity, that means it is a 5 volt voltage drop here, 10 volt voltage drop here, 5 volt voltage drop. These particular polarities are the values of this potential voltage drop polarities only. Next, at the last point here, point B and C, similarly point D and E cannot be different potential because they are connected by piece of conductor by zero resistance. In the previously I mentioned what is mean by zero IR drop. In case of your interconnecting wires, what about the IR drop is zero? Already mentioned that point here mentioned. B and C, any element is connected? No, only interconnector wire is connected. That means what is IR drop is zero. That's what they mentioned. Similarly, and D and E also connected interconnecting wires. What is the IR drop is zero. You don't want to consider those IR drops. That is a point here. So this is all about the polarity of IR drop. Everyone is clearly understood that what exactly the IR drop? Yes. So still we are completed up to polarities of IR drops. Next we are moving to the another topic. Next to total power. In your syllabus, the next topic is the total power. So total power in case of series circuit, till now we discussed about the total resistance, the current is same, total voltage drop. What about the power in case of series circuit? Look at here. This is the circuit we have. So in this particular circuit, the power P1, the power consumed by the resistance R1 is P1, resistance R2 is P2, resistance R3 is P3. Let me, for example, in this case, total power supplied from the battery, P is equal to sum of the power consumed by the resistors. This is a total power in case of series circuit. So see here, the power needed to drive the current through different resistors appear in the form of heat. That means P is equal to appear I square R. Right, here P is equal to I square R2. Here P is equal to I square R3. That means it is the particular power is dissipated as a heat. Right, heat, as total power supplied by the energy source must be equal to the sum of the individual power dissipated in the resistor. That's what here total power is equal to P is equal to P1 plus P2 plus P3 and so on. So this is one of the important point you need to remember. In the examination, you may expect the question in the numerical manner. They will provide the one circuit. They given total power and one of the two resistance power. What about the power consumed by the another resistor? Let me take that example also. See, look at here. Here total power supplied by the battery is 30 watt. It is a 10 watt power. It is consumed by the 10 watt power. P1 and P2 are consumed by 10 watt power. What is the power P2 power consumption? You know, from this example, 30 is equal to P1 is 10, P2 you need to find out, P2 is 10. What about the P2 value is 10 watt? So that's what you need to find out. You know this particular concept, then only you are able to answer those questions. So I hope that you are enjoying this particular explanation class. All 5 units I will explain the same manner. But our schedule, you know, 31st of January, I will finish the total 5 units. If you are interested, you can go to our mobile app, you can download it. Not only I explain the theory classes, I explain the previous year's questions from the chapter wise, topic wise, and the explained separate video I make it for the objective questions of previous year's question paper, and then I will provide the test series for each and every topic. I will provide the 2 test series after once you have completed the syllabus. After that, overall test series for the unit 1 and unit 2 and unit 3 and unit 4 and unit 5 as well. Once you completed all the test series, before 1 month before the examination, I will conduct the full length test series for all 5 units. Around 5 full length test series I will provide. So this is a way, based on the exam duration, that means based on the exam date, I will plan the syllabus completion. So in case of exam date is prior to that, I will complete the syllabus before that only. Okay. Next one, series adding, series opposing voltages. This is the next topic. So I will explain now clearly what exactly means series adding and series opposing. Let us take series adding. So first of all, everyone look at the circuit here. 6 volt and 6 volts battery connected. This is the positive polarity, this is the negative polarity. This is the positive polarity, this is the negative polarity. All this circuit is a series connection. Current will be the same for R1 as well as R2. My question here, this positive polarity connected to the negative polarity of the first battery, second battery, that means according to the Coulomb's law, same polarities are repel each other, opposite polarities are attract each other. In this case, opposite polarities are not. Whenever these two are opposite polarity, what about the total voltage now? 6 plus 6, 12 volt. All of you got my point. This is a series adding. Series adding means that whenever the positive polarity connected to the negative polarity of the battery, then it is a possible for the series adding. Okay, everyone clear about that? Just look at here. In series adding combination, the voltage source or cells or batteries are connected in series. Okay, it is connected in series such that positive terminal of the one is joined to the negative terminal of the next. That's what I explained. Positive terminal of the one end is joined to the negative terminal of the another end. Okay, right, another end. In this case, the total voltage across the circuit is sum of the voltages are battery EMFs. So here voltage V is equal to 6 plus 6, that is equal to 12 volts. That is nothing but a series adding. So everyone is clear, right? Then we are moving to the next, opposing, series opposing. So look at here. This is a positive terminal, this is a negative terminal. This is a positive terminal, this is a negative terminal. According to Coulomb's law, same charges are repel each other. That means here definitely the resultant voltage is a subtraction, opposing. So total voltage is equal to 6 volt. 12 minus 6. That's what here. In series opposing combination, positive terminal of the one of the voltage source is connected to the positive terminal of the other source. Yes, positive terminal of the one source is connected to the positive terminal of the other source. In this case, the next voltage is difference of the two voltages at the same polarity of larger voltage drop. This is very important. For example, here 6 volt is more voltage or 12 volt is more voltage? 12 volt. That means 12 minus 6. What is the polarity of 12 volt? Is a positive, right? 12 minus 6 is a plus 6 only. Okay. So that's what here total voltage is equal to 12 minus 6. That is equal to 6 volt. This is about the opposing. In case of opposing, one of the important point, the polarity of the two voltages is the largest value polarity you need to consider. Largest value of voltage source polarity you need to consider the resultant value. In this case, it is a positive. Okay, this is explanation about polarities, series adding and opposing voltages. Okay, example 2.1. The problem here, compute total circuit resistance, circuit current, potential difference between A and E. After that, power supply, potential of point E and power supplied by the battery. These are the points you need to find out. In the examination, these type of questions, they won't ask all the bits at a time. They will give the circuit, ask any total current or potential difference or power supplied by the battery. Some questions they will ask. So the first point here, total circuit resistance. So how to find out the total circuit resistance? See here, this is a circuit. We have R2 and R 3 ohm resistance and 1 ohm resistance, all together connected in series, because the current will be flowing the same path. In the series circuit condition, current is same. Whenever current is same, R equivalent, that is a total resistance, is equal to 2 plus 3 plus 1. That may be equivalent to 5 ohms. Is it okay? That is about the 5 ohms. Second, in the second case, circuit current according to Ohm's law, I is equal to V by R. Okay, here V is a 12 volt. What about the R equivalent? R equivalent circuit resistance 5 ohms, that will be equivalent to 2.12 by, I'm sorry, here 2 plus 3 plus 1, 6 ohm. Okay, here 12 by 6, that will be equivalent to 2 amperes. So all of you clear about that? R equivalent is equal to 2 plus 3 plus 1, that is equal to 6 ohm. Next, third bit. What about the third bit? Potential between A and E. So potential between A and B means VAE is equal to, VAE means this two terminal, what about the resistance? 5 ohms. V is equal to IR, right? 5 into, what about the current flowing through this particular circuit is 2 amperes, already found, that is equal to 10 volt. All of you got my point? Next, fourth point. What about the fourth one? Voltage. I will see the fourth one. Potential of point E. So point E potential means here the potential between ground as well as these two terminal, that is a VE, right? So VE is equal to, so what about the current here? V is equal to IR, right? I is 2 amperes series circuit. What about resistance? 1 ohm, that is equal to 2 volt. Okay, it is with respect to ground, it is a positive. We should mention positive voltage. So it is above the ground. In the first unit I explained about zero reference point, right? According to that concept, it is a positive. Next, fifth one. What about the fifth one? Power supplied by the battery. Power supplied by the battery, P is equal to V into I. So what about the V? 12 volt. What about the current 2? That will be equivalent to 24 watts. Okay, this is the way you need to analyze the circuit. Next, example 2.2. In the circuit shown in the figure 2.8, yes, calculate the circuit current, right, as well as potential of point C, the potential of point. So next, potential of point B. Here potential of point B and point of lowest potential. You need to, after calculating that, you can tell you value of lowest potential, point of lowest potential and value of lowest potential. We will discuss one by one. So the first one, circuit current. How to find out the current according to Ohm's law? I is equal to V by R, right? This particular circuit, it is a series circuit, right? 160 connected in series. So total voltage is 24 divided by 160. Okay, 24 divided by 160, that will be equivalent to 0.15 amperes. That is the first part. Next, second. In the second part, potential of point C. Where is the point C? C point directly connected to the ground, right? What is the ground potential now? 0 volt. So point C, ground potential 0 volt. Vc is equal to 0. Right. Next, second one. In the third point. Third one, potential of point B. Where is the B? Here. Okay. So potential of point B, that is a VB is equal to, Ohm's law, V is equal to IR. What is the I? I value is a 0.15. And potential of B point is nothing but the voltage between these 2 points, that is a VB. VB is equal to, it is a plus with respect to above to the ground, right? Plus I into, what is R? 60. That will be equivalent to I into R plus 9 volt. Is it okay? So next, fourth bit, point of lowest potential. Point of lowest potential, point A is the lowest potential, that is, it is a point A is the lowest potential. This is the point A, because it is a maximum negative potential. Point A is the lowest point. So point A is lowest. I will explain why it is the lowest potential, because at potential VA, if you are consider potential VA with respect to D, it is a minus 24 volt. It is a minus, negative is connected here now, minus 24. Okay, so not minus 24 exactly, the voltage between these two with respect to this particular ground. I will explain. VA is equal to, what about negative of current 0.15, current into resistance. What is the resistance here? 100, right? This is a 100. That will be equivalent to 15 volt. Minus 15 is the lowest potential. Okay, this particular circuit. Next, lowest point. What is the value of lowest potential? The value of lowest potential is equal to 15, minus 15 volt. So this is a fourth point. Point A is a lowest point. The value of lowest point is minus 15 volt. Okay, this is a bit for the fifth bit solution. I hope that everyone is clear. Once again, I will repeat the fourth and fifth bit. Carefully listen. Point of lowest potential. The point of lowest potential means the point A is connected to the ground, but it is connected to the battery of negative terminal, right? So that's why with respect to ground, it is a negative potential. That's why it is the lowest point. Next one, the value of lowest potential with respect to ground, we are going to calculate the current flowing through this 100 ohm resistance is 0.15. It is apply the Ohm's law. V is equal to IR minus 0.15 into 100, that is equal to 15 volt, minus 15 volt. Okay, right. So here, with reference to the circuit shown in the figure, the first point is circuit current you need to find out. The first point, circuit current. Circuit current I is equal to V by R, right? R equivalent. So, but here two batteries are connected with polarities as here, plus and minus, plus and minus. Whenever positive, same polarities are connected according to Coulomb's law, same charges are repel each other. Repel means that subtraction in this mathematical terminology. That means 12 minus 6. 12 is the highest potential. 12 minus 6 divided by, what about resistance? Resistance is series, right? In case of series, 8 plus 4, that is at 12. That will be equivalent to 6 by 12, 0.5 amperes. Okay, the first part is done. What about the power supplied by the batteries? So second bit, power supplied by the batteries. So the power supplied by the batteries here, see here, it is a 12 volt, it is a 6 volt. 12 volt is the highest potential, but polarities are oppositely connected. Whenever oppositely connected, definitely this battery supplies whatever may be the current is charged or consumed by 6 volt resistor. That means 6 volt resistor consume power because it is oppositely connected to the 12 volts battery, opposite polarity. What about 12 volt resistor? 12 volt resistor consumes the power. The power consumed, P is equal to 12 ohm resistor, that is a P12, otherwise P is equal to V into I. What about the V12? What about the current 0.5? It is equal to 6 watts. 6 watts is a power consumed, power delivered by the 12 voltage source. Okay, 6 volt is a power consumed. Coming to the third point. And the third point, power dissipated in two resistors. Power dissipated in two resistors, that is a P1. Power dissipated in the first resistor is equal to I square R1. What is I square? 0.5 whole square into What is R1 4? So 0.5 whole square into R1 4, that is equal to 1 watt. Is it okay? Next, power dissipated in the second resistor P2. P2 is equal to I square R2, that is equal to 0.5 whole square into 8, that is equal to 2 watt. So all of you carefully listen. My question here, what is the power supplied by the 12 volts battery? 6 watt. Okay, it is 12 volts battery, 6 watt is power supply. What is the power consumed by the P1? P1 power consumed is equal to 1 watt. P2 is equal to 2 watt. What about the total power consumed? 3 watt. But what about the power supplied by the battery? 6 watt. Where is the 3 watt power? Power consumed by these two resistors is a 3 watt. Power supplied by the 12 volt resistor is a 6 watt. What about the remaining 3 watt is power? 3 watt is power consumed by the 6 voltage resistor. What is the power consumed by the 6 volt resistor is a 3 watt. That is consumed by the this 6 volt resistor. That is a consumed power by the second resistor, that is a 6 P6. Otherwise we can V into I need to prove that what is a V6. It is a 0.5, that is equal to 3 watt or not? Yes, that 3 watt, remaining 3 watt is 3 watts consumed by the 6 volt resistor. I hope that everyone is clear. Next, coming to the fourth point, potential of point A with and its polarity, right? So fourth point, potential of point A with respect to and its polarity with respect to C. You can calculate potential of point. How to calculate? The voltage across these points is nothing but a VA. So this current is 0.5 amperes. 0.5 amperes. So VA is equal to current into resistance. What is the resistance? Resistance is equal to 4 plus 8, that is equal to 12. That will be equivalent to 12 into 0.1, that is a 6 volt. Plus 6 volt is a voltage value. Next, coming to the fifth bit. So fifth bit is the last one. Potential of point B and its polarity. So potential of point B means that in between these two. So what about the current here? The same current, series circuit. So VB is equal to plus current into 0.5 into resistance. What about the resistance here? Resistance is 8 ohms. Only 8 ohms you need to consider. That will be equivalent to plus 4 volt. That is a polarity with respect to C. Okay, with respect to C, that is a 8 volt. Sorry, 4 volt. This is about the solution. Next, example 2.4. For the circuit shown in the figure, this is the circuit we have. So the first point here, power delivered to the element A. The power delivered to the element A. So the power delivered, P is equal to, for example, PA is equal to current. Already given current, I is equal to 5 milliamperes. 5 into 10 power 3 into P is equal to VI. What is the voltage? 4 volt. That will be equivalent to 4 5s at 20 milliwatt. What is the power delivered by the first element A? The power delivered to the first element, that is the power consumed by the element A, is 20 milliwatt. Next, power delivered to B, that is a power consumed by the B, that is a PB is equal to, again the current, it is a series connection, current is same, that is equal to 5 into 10 power 3. But you don't know the voltage, right? We can find out the voltage with the help of the KVL. So I am going to apply the KVL here. Whenever I am applying the KVL, so here plus and minus. So I am going to write the equation minus 12. So here different conventions. Based on your convention, you can take positive or negative. I will follow the one convention throughout my explanation, throughout all 39 chapters. Negative to positive, the negative terminal arrow is entered minus. Here here positive terminal arrow enter, so plus 4. Here plus terminal arrow is entering, that means plus VB is equal to 0. From that VB is equal to 8 volt. Okay, clear? This is the one of the convention. So another convention I am also explaining to you for your understanding purpose. So in this case, this arrow, another convention will get the same result. For your understanding purpose, which convention you are easy to you can follow that convention. This arrow from negative to positive, that means raising potential. In that particular case, you can take it as a positive. Here plus 2 minus fall in potential, that will be minus 4. This one plus 2 minus fall in potential, that is a VB is equal to 0. From that, VB is equal to 8 volt. In the both the cases we will get the same value. We can follow any convention according to your comfortability. So here 8, so that will be equal to 40 milliwatt. Okay, all of you following? Next, at the last, voltage drop across the element B. Voltage drop across the element B, just now we calculated, this is a B. Voltage drop across the element VB is equal to 8 volt. So this is about the solution.